Hello friends, welcome in compiler designing class. In today video session, we will discuss what is grammar with common prefixes and what is left factoring method and what kind of problem that could arise if your grammar is having common prefixes. Now, in previous session, what we discussed is that what I said is that grammar is of two type. It could be ambiguous grammar, it could be unambiguous grammar. And I already told you that ambiguous grammar always leads to incorrect result. So your grammar should be unambiguous. Similarly, what I said is that the grammar is again of two type. Either it will be left recursive or it will be right recursive. So most of the top-down parser, they do not prefer left recursion. So your grammar should be right recursive. In the same series, the third category on which I can divide or I can categorize my grammar is that your grammar could be either deterministic grammar, your grammar could be either a deterministic grammar or it can be non-deterministic. It can be non-deterministic. So there are two type of grammar. One is called deterministic and another one is called non-deterministic. And in compiler designing, while we are using a top-down parser, your grammar should be deterministic. It should not be non-deterministic. And this non-deterministic grammar is called the grammar with common prefixes. The grammar with common prefixes. So the idea is that in this video session I will tell you what do you mean by deterministic grammar and what do you mean by non-deterministic grammar, and what kind of problem comes if your grammar is non-deterministic and how to solve this grammar. So the idea is that if your grammar is non-deterministic, you have to make it deterministic, this one, and to do this we are using a method, and that method is called left factoring method. Left factoring method. So the question is, what is left factoring? Left factoring is a process which convert a non-deterministic grammar into deterministic grammar. So we will see that what kind of problem comes when your grammar is non-deterministic and how it works. So let's start with, okay, just see, this is the definition of non-deterministic grammar, and you can also say a grammar with common prefixes. And what it says that if right hand side of more than one production, if right hand side of more than one production starts with the same symbol, then such grammar is called non-deterministic grammar or grammar with common prefixes. I repeat it, if on right hand side of a grammar more than one production starts with same symbol, then that grammar is called non-deterministic. Just for example, just see this example, that there are three production rule, A, 2 and 3, and if I write them in line by line, so it will be like this: alpha, beta 1, second one alpha, beta 2, and third one alpha, beta 3. And as you can see that in all these three production, left hand side same non-terminal And right hand side, just see alpha, alpha and alpha. So you can say in these three production rule, it has a common prefixes. Prefix is alpha, alpha in production number 1, alpha in production number 2 and alpha in production number 3. So you can say that this grammar is a non-deterministic grammar, or a grammar with common prefixes. But it will create some problem. We will see that what is the problem with this one. Uh, just assume that I want to generate a language, um, for example alpha beta 3. I want to generate this language. Can I generate this language using these production rule? So can I use production number 1? Just see that production number 1 says that A can generate first alpha. Just see, A can generate alpha. So here it is alpha. It's okay. And I also need alpha as my first symbol. But if I use this production, what I will get? I will get beta 1. So I got the wrong tree. So I have to backtrack because this production is not useful. I will come to second case. A, I will use second production. It says alpha and then beta 2. So again alpha is okay according to my desired language, but we got beta 2 this time. So again we have to backtrack, we have to come to our first root, and then I will choose production number 3, and what it says alpha and beta 3. So now you got the language, and language is L is equal to alpha beta 3. But the problem is that since they have a common prefixes, so you can use production number 1, but at one moment you realize that you are getting the wrong answer, so you are going to backtrack. Then you are using production number 2. Again at this moment you realize that it is a wrong production, so you backtrack, and in third case you come to the desired result. Now this is the problem, and this is called non-deterministic problem, because in a single go, in a single hand, it is not possible to determine should I use this production or this production, because alpha is common in all these three production. So we have to convert this production, which is a non-deterministic production grammar, and this grammar yields you incorrect result. You have to backtrack again, you have to try. If you got beta 2, again you have to backtrack, and then you have to try again. So we have to overcome this problem, and to overcome this problem we need a deterministic grammar where we should not have a common prefixes. So we will use the method, that method is called left factoring method. So left factoring, as I said earlier, it is a process by which the grammar with common prefixes is transformed. Transformed means that we have to eliminate the production rule which have common prefixes. And how to do this? Just see a simple one. First of all, we make one production for each common prefixes. Just remember that first we have to find out the common prefixes, and for all the production which have common prefixes we have to convert them into single prefix production. Now common prefixes may contain terminals, non-terminals, or both. So while counting the common prefixes, it may have terminals, small letters, it may have non-terminal, capital letter. And The rest of the derivation is added by new production. We'll take some examples so it will be clear. Just see that if I say that we have a production called A derive A B. This is the first production, and then your second production is again A and then B, and your third production is B is equal to small b. Just assume that these are the three production rule that you have, and you have to find out whether it is a non-deterministic grammar or deterministic grammar. So as you can see that in first two production, left hand side non-terminals are same. On right hand side you can see that A is common in these two production. So what the rule says that we have to make one production for these two common prefixes, and for rest of the symbols we have to make a new derivation. So how to do this? We will take some examples and it will be clear. Okay. So just assume that this is the production rule, and you can see that these production rules are production rule number 1, rule number 2 and rule number 3. Now is in this type of question it is very good if we can make each production line by line. For example, A alpha 1, next A alpha 2, next A alpha 3. Now so these three production it is much easier if we write it in line by line. Even this is also okay. Now as you can see that in all the three production A is common. So what we will do is we will take a production rule A. It generates what is common in these three production, that is A. So I will write A, and then rest you can see alpha 1, alpha 2, alpha 3. So the common thing we will write once, and then we will write A dash, means to generate alpha 1, either alpha 2 or alpha 3, it is the responsibility of a new terminal, a non-terminal, that is A dash. And now in next line A dash is equal to what A dash can generate according to these production rule, alpha 1, alpha 2, alpha 3. So I can write alpha 1, alpha 2 and alpha 3. So now if you see that in these two production, on left hand side we have A and A dash, nothing is common. On right hand side also if you see, A has single production, A dash has three production, alpha 1, alpha 2, alpha 3, but nothing is common. So we just avoid that backtracking issue. For example, just see that if I have to generate a language A alpha 3, according to this one it will be you have to first check production number 1, it's not good, alpha 1 is there, alpha 2 and alpha 3. But in this case I will start from A, it will be A and A dash, and then from A dash you can directly generate alpha 3. So there is no backtracking. You can understand that there is no backtracking. So this is the advantage of using a deterministic grammar. So this is your deterministic grammar and this is non-deterministic grammar, and this process is called left factoring, which convert non-deterministic grammar into deterministic grammar. We'll take another example. Just see in this example also we have three production rule, and first of all we will see what is common in these three production rule. A, okay, here also A, here also A. So in these three production rule, A is common. So how to generate this? Just see, S is equal to, what is common? That is A. Okay, and rest, whatever left, the responsibility to generate the rest of the symbols is given to S dash. S dash. Okay, so what left uh, other than common prefixes, the responsibility to generate all those symbols is given to S dash. And now what S dash will do? Just see, S dash equal to what S dash can generate, this one which is not common, that is S S B S, or it can generate ASB, or it can generate whatever left after common prefixes, that is B B. So as you can see that okay, here it is S A S B. Now this production is okay, I count it. Now again if I check here, we have something common, S S. So what should I do? Again apply the left factoring over here. Now this production is okay. Now if I apply this, so what is this? S dash can generate what is common in these two? You can say S. So S is common. What left? This part. The responsibility to generate these two parts will be given to S double dash. I can write like this, and here it is okay, there is no issue, so I will write BB. And now what S dash can generate? What is left? SBS. SBS slash ASB. Now again you have to check, is there anything common? No, there is S, there is S. So total how many production? Production number 1, which we have generated in step number 1. Then again we got some commons, so this is my second production, this thing, and this is my third production. So total how many production we got? 1, 2 and 3. So this is your answer. We will take some more examples. Okay, let's see this one. We have 3 production rule. A generate A capital A B, A generate small a capital B small c, A generate small a capital A, and this thing. Now if you see what is common in these 3 production, A and A. So what we will do, whatever is common we will take it once, A, and then the responsibility to generate this one and this one is given to some other terminal, for example A dash. Now what A dash can generate? AB capital AB slash BC, this part, slash AC. So this is your new productions that we receive. Now if again you see that we have common prefixes A and A, but you can see that here it is A dash. So what we will do, again we have to convert these common prefixes into using left factoring. So what it will be, A dash is equal to, what is common? A. So A is here, and what is left? Here B and here C. So responsibility to generate B and C is given to another non-terminal, that is called A dash, A double dash, and this BC is okay, there is no common prefix here, so we will write it BC. Now we have to solve this one also. A dash double dash is equal to what A double dash can generate, B and C. So we will write B and C. That's all. So total how many production we got? We got production number 1 here, then we got production number 2 over here, and then we got production number 3. See, this production I have expanded, so I should not count this one. I will count this one. Then from A dash I can generate this one, and then from double A dash A double dash we can generate this one. So this is your left factoring method. Take another example. Just see, it's very simple one, that S generate A, S generate AB, S generate ABD. So what is common in these three? A and A. So what we will do? S generate A, this one, and what is left? See, here left nothing, and nothing means epsilon. Just remember this. If A is okay, so what is left? Nothing, and nothing means epsilon. Here left B and here left BD. So I can say that this will be generated by S dash. So what S dash can generate? S dash can generate epsilon, this nothing, epsilon, then it can generate B, and then it can generate BD. So this is your refinement. Now again, if you check that B is common in these two, so what we will do? Again we will do the left factoring. S dash generate, what is common? B, and if B is okay, then what is left? D over here and epsilon over here. So we say the responsibility will be given to S double dash. And now what S double dash can generate? It can generate what is left? D and epsilon. So this is your production number 1, this is your production number 2, and this is your production number 3. So these three are deterministic grammar of this one, which is a non-deterministic grammar. Okay, we will take another example. Just see, now how to read this type of statement is if, else, then statement, if, else, then statement, else, statement, slash A and slash B. Now if you see minutely, you can see out of these three, this production is okay, there is nothing common with E, but here as you can see this thing, and here you can see this thing, these all symbols are common. So we have to convert this using left factoring. And what left factoring? See, what are common things? I, capital E, T, S, this is common. So whatever is common, we will take it once, and then what is left? Here left nothing, and nothing means epsilon, and here left this 2. So the responsibility to generate epsilon and ES will be given to S double dash. And now what S double dash can generate? Epsilon or ES. And since here it is okay, A is there, so we can write it here itself. That's all. So this is your deterministic grammar, and this is your non-deterministic grammar. So it's very easy, just we have to do practice, and we have to follow the approach that after reducing the common prefixes, if we got another common prefix, then we have to keep applying the same process. So that is what the left factoring says and what the left factoring do. Thank you very much.